All right, so we're going to look at your 2.7 ready, set, go. Let's go ahead and start with your ready. These should go pretty quick. It's just getting you guys to create 4 tables, and then you're matching these 4 tables with the graphs over here. So you need to pick your values for X. Actually, they're already picking those for you. You're going to plug those in for X. And then you're going to plot those points on the graph. I would use 4 colors. Pick 4 colors, do your table in that color, and then find those points. For example, I'll use red for number 1. So -3 to the 1 is -3. -2 to the 1 is -2. -1 to the 1 is -1. So I see a pattern here. It's just repeating 0, 1, 2, 3. So recognize these patterns. So with my red pen, I am going to find those points over here. So I'm not even going to look at the graphs. I'm just going to plot the points. So -3, -3. Hey, look, that's the only one it's on. So I'm going to just keep going, just so I have more points to put together. But I can see that this one is my line. Okay, so I have that one drawn. Now I'm going to change colors, and then I'm going to do number 2, change colors 3, change colors 4. So you guys can finish going through and doing that. For the larger numbers, you may want to go ahead and use a calculator. Be careful with your exponents. Back here, number 1, I probably should have went ahead and used parentheses. Ignore that, that's popping up. I should always put parentheses around what I'm plugging in, so I went back and did that. Be careful with that on number 2 and number 4, because now you have an even exponent. And think about what that does to a negative. So in B, or 2, sorry, I'd have -3 squared, which is going to end up being +9. So be very careful with that. The negative will go away now because it's squared, where in number 1 it did not go away because it's not squared. So 2 negatives will always make a positive. Don't forget that. Once you have your graphs chosen, now you're going to answer 6 and 7. Identify the point where all the functions are sharing. Then you're going to explain why you think it works with that point. Okay, and it should be pretty obvious. Kind of use the equations to make your explanation. And then in number 7, you're contrasting them, which is what is different. You're not comparing them. You're not finding where they're the same. You're just contrasting them. How are they different? So you can use them as number 1, number 2, number 3, number 4. You can use by their color. But talk about how they are different, please. How is an even power, okay, an even power, which is the 2 and 4, different from an odd power, which is the 1 and 3? So that would be the exponents of 2 and 4. That would be an exponent of 1 and 3. And that's even how they have them numbered. Even exponents, 2 and 4. Odd exponents are 1 and 3. So that's what you guys are going to go through and use for your ready. Now on your set, I actually want to help you a little bit with this one. This is kind of a struggle through this because we just finished a task where we're using these exponential functions with the natural exponential, which is the E button, but now we're given a situation where we are not using the natural exponential equation. We're actually going to use the exponential that we would have used in Math 1. So we have a certain population that is known to double every 15 minutes, and there are initially 7 bacteria. So that's enough to actually make my table. So that's what I'm going to start with, is my table. So at time 0, there are 7 bacteria. But then it wants hour 1. Hour 1 is not 14. Hour 1 has been doubled 4 times. It has been doubled 4 times. So doubling, so 4 times it has been doubled. So that is actually 4 to the second. But I'll prove it to you. If I double 7 after 15 minutes, there's going to be 14. After 30 minutes, there's going to be 28. 45 minutes, there'll be 56. And then after a whole hour, 60 minutes, there's going to be 112 bacteria. So it has doubled 4 times. Okay, it went through that process 4 times. Then I would start doubling again and again and again and again, and that is very time consuming. But when I went through and I did this one already, I found this, and then to find my ratio, it's your second term, which is the 112 divided by your first term, which gives me 16. And where is that coming from? 4 times I doubled it, 4 squared. 4 times I doubled it, or I doubled it 4 times. Okay, this is one of the nice ones. So whichever way that makes sense to you, 2 squared and 4 squared, 2 to the 4th and 4 squared are both the same thing, but I doubled it 4 times, and that gives me 16. So you're just going to keep going through and multiplying by 16 to get to each step in the box. Multiply by 16. Then you're going to make your graph, and it says on the graph, you're going to use increments of every quarter of an hour. This will allow you to fit more. So this would be 15 minutes, 30 minutes, 45 minutes, 60 minutes, and just keep going and going and going. And then scale your y-axis appropriately, please. You might need to go by 10s. You might need to go by 20s, whichever you are going to need for 4 points. You need 4 points on your graph. Now for writing the equation, I'm going to use y equals, or f of x equals, actually let me use that. F of x will equal a sub 0 times r to the x. A sub 0 is your term 0, and r is your ratio. It's what you are multiplying by. So you're going to get all that from your table to finish writing your equation. Once you have that, you can now answer questions 9 through 12. Between what times to the nearest quarter of an hour will the number of bacteria exceed at 10,000 and then exceed a million? So you guys are going to actually plug in for f of x. This would be f of x, and this would be f of x. And then you have to go through and solve for x. Now, don't forget we are using logs here. Your x is an exponent. So I will go ahead and start you with the first one, which is the 10,000. So I have 10,000. I want it to exceed 10,000. So the bacteria has to be greater than or equal to, I'll just go with greater than 10,000. So I'm going to hopefully have this for my equation. I have 7 bacteria to start with. 2 to the 4th is 16 to the x. So it says between what times to the nearest quarter of an hour. Now, you could use your table. You're welcome to use your table. You're welcome to use your graph. I wouldn't. I would just find the minimum time for 10,000. And I would start by dividing by 7. Let me get my calculator, which is going to give me 1428.57, but I leave the decimal in my calculator, equals 16 to the x. Since x is an exponent and that's what I have to solve for, I'm going to log both sides. So I get the log of this 1425.57 equals x times a log of 16. So I'm using the power property, moving the x to the front. Now I can divide by log 16. So I have this decimal, the 1400, already in my calculator. So I'm going to go log second answer, and then I'm going to divide that by log of 16. And x is going to equal, x has to be greater than 2.6 hours. So you could say between the 2 hours and 45 minutes and the 3 hours is what it would end up being. since it wants it to the quarter of an hour. But you're also welcome to use your table, you guys, and just keep figuring it out. That's fine. This thing is actually going to grow really, really fast. Its growth rate, since it's doubling every 15 minutes. So you'll find your answers pretty quick if you make a table. Then you're going to predict the number of bacteria after a 24-hour period. You're going to need to use your calculator. This is what you would plug in for X, 24 hours. Write a logarithmic equation that would allow you to find the time when there are 700 bacteria. So what I did here in the red, that's a logarithmic equation for 10,000 bacteria. You are going to write a logarithmic equation for 700 bacteria. And then you're just going to solve it. So it's having you go through and use the equation, but I already had you guys do that for 9, so you guys are going to get extra practice on that. And I really am okay with you guys just saying equals on number 9. You don't need to worry about exceeding. Just go for when it equals 10,000 and equals a million. So that way you guys can just say, oh, about 2.6 hours. You don't have to say it's between any such time, because time is continuous. It does get to keep going. It doesn't stop and it doesn't skip. So that's the set. Hopefully that makes sense. You're just working through a lot of logarithmic equations. Now, when you get to the go, I love these problems. I really, really do. It gets you really thinking about your fractions and the numbers that you are given. Here, I have log base 2 over 3. And I have to find that using these numbers that I am given. My base is 10. That doesn't help me at all. I have to use a 12, an 8, and a 7. And you may have to use some multiplication here. You may have to really think outside the box. Hold on, I'm yawning. Sorry, excuse me. I'm going to start by, if I multiply this by 2, I get 4 6. Okay, I don't have those numbers there. What if I multiply by 3? I get 6 9ths. Don't have those numbers there. If I multiply by 4, I get 8 12ths. Oh, look at that. I have 8 12ths, and I've got 2/3. When I divide by 4, so this is what I did. I multiplied by 4, and I multiplied by 4, and I get 8 over 12. So this is the same as log of 8 over 12, which is now a fraction, so I can write it as subtraction. So I have the log of 8 minus the log of 12. So sometimes they'll have the fraction so simplified that you can't find the number, but just keep multiplying, and then you will be able to find it. So here 1/7 multiply by 2, multiply by 3, multiply by 4, multiply by 5, and you will be able to get to it eventually. Same with, well, 15 is easy. You should be fine with 15. On 16, if I multiply by, let's say I multiply by 4, because I need to make a 12. I multiply 14 by 4. I get 12 over 64. That works. This will be just fine. So this is the log of 12 minus the log of 64. Now, why is that okay? Well, I can rewrite the log of 64. This is the same as 8 squared. So now I can take my exponent, use the power property, and move it to the front. So this ends up being, let me write this off to the side, log of 12 minus 2 log of 8. Now I can plug in. Log of 12 is 1.1. Log 8 is 0.9. So 1.1 minus 1.8. And then you can find your answer, negative 0.7. So don't overthink this, you guys. You may not get exactly the 12, the 8, or the 7, but you can find other numbers that you can then break apart or write differently. So you can get 12, 8, and 7. And then when you guys get to 18 and 20, those are kind of tricky because they equal a variable, but don't worry about that. You're still trying to break apart the 729 using 6, 9, and 7. But don't forget, because now I have a base, I can also use log base 8 of 1 and log base 8 of 8. This equals 0, that equals 1. So through all 4 of these ones that you can see right now, 17 through 20, you can also use other numbers. But if you notice, some of these are similar to what we have already used. For example, 17, you will have already broken apart 729, but now you're just going to take and put a variable instead of a decimal. So don't work too hard on those, but you're really going to have good multiplication skills so you know the multiples and the numbers that you are looking for. So that concludes the 2.7 video. You guys will be working through this on the weekend. And on Monday when I get back, I know I haven't seen you guys for 3 days. When I get back on Monday, we'll go over any questions that you guys have. And feel free to email me if you're stuck on anything. I will help you guys with that as much as I can. All right, see you guys on Monday.